In the name of Allah, the most gracious, the most merciful. Good morning, everyone. Now we are going to deal with our new program for mathematics department in Tabarak Private School with you, teacher Mohammed Albadry, with grade 11 mathematics teachers, and we are going to deal with the lesson of the sum to infinity. And before everything, we have to say big thanks for the chairman, Mr. Yunus Rahbi. Now we are going to start with our new lesson, the sum to infinite.
How are you, my dear students? I am Mr. Mohammed Badri, teaching grade 11 bilingual. Welcome to our private school, Tabarak. From our educational platform, we have to thank our chairman, Mr. Yunus Rahbi, who gives us this wonderful opportunity to contact with our dear students. And today we are going to study new lesson in algebra, which is binomial theorem. Binomial theorem here, how could we find the expansion of binomial raised to, and the binomial theorem to find any term of the expansion of a plus b power n can be found using the formula of tr plus 1 equals the combination of n choose r times a power n minus r times b power r. So here r is the order of the term minus 1. So how could we find it? The first example here for the binomial 2 minus x raised to the power of 10, find the first 4 terms, the sixth term. Sure, we have to use the formula. So the answer now here, we have a equals 2, b equals negative x, and n equals 10. So when we are going to use r now here, the order of the term minus 1. So for a, the first 4 terms using the formula is here 10 choose 0 times 2 power 10 minus 0 times negative x power 0 plus 10 choose 1 2 power 10 minus 1 times negative x power 1. The third term 10 choose 2 times 2 power 10 minus 2 times negative x power 2 plus 10 choose 3 times 2 power 10 minus 3 times the negative x power 3. For the numbers we can use the calculator 10 choose 0 using the steps of 10 shift divide 0 and CR. So now here when we do it, the first term doesn't have any x's. It will be 1024, and the second term will be negative 5120x. The third term will be 11520 x squared, and for the fourth term it will be 15360 x power 3. Here for the first equation a. Now for the second equation b, find the sixth term. To find the sixth term, we have to know that a equals 2 and b equals the negative x, and n is 10 and r is 5. 6 minus 1 equals to 5. So T6 equals 10 choose 5, n choose r, 2 power 10 minus 5 minus x power 5. For the numbers, we can put it directly using calculator. 10 shift divide 5 to find the combination, multiply by 2 power 5, we will have it negative 8064 times x raised to the power of 5. Here for the first example. For the second one, how could we find the middle term in the expansion of a plus b power n? So in general, for the binomial expansion a plus b raised to the power of n, we have two cases. If n is even, that means we have the expansion and the number of these terms, then the expansion will be odd. We have only one middle term if we have an even, so the order is n over 2 plus 1. But if we have an odd, that these exist two middle terms, because we will have even expansion, even number of terms of expansion, so n plus 1 over 2 the order, and n plus 3 over 2 is the order. To know how could we do it, here we have an example. Find the middle terms of 2a minus 1 power 9. So now here we have to ask ourselves very important question: 9 here is even or odd? 9 here is odd number, but the expansion it will be even, so we will have two middle terms. So now here 9 is an odd number, there are two middle terms. The order of the middle terms, 9 plus 1 over 2, 5, and 9 plus 3 over 2 is 6. So now we have to find the first term and the sixth term. For the first term, it will be 9 choose 4, 2a, the first term, raised to the power of 5, which is 9 minus 4, and the second term, negative 1, raised to the power of r, which is 4. And finding using calculator, you will have it 4032, a power 5. Now for the sixth term, 9 choose 5 times 2a raised to the power of 4, because 9 minus 5 equals 4, and negative 1 power 5. Again, using calculator, you will have it negative 2016, a power 4. Now for the next example, here we have find the middle term of 2x squared minus 1 over x power 12. 12 here is even, so we have only one middle term, which is order 12 divided by 2 plus 1 equals 7. So the value of the seventh term equals 2, 12 choose 6 times 2x squared power 12 minus 6 times negative 1 over x power 6. We will have 12 choose 6 to simplify it, and here we have negative x power negative 6, and put it using calculator, we will have it 59,136 x power 6. Now for the exercise here, find the term contains x power 8 in the expansion of 2x squared plus 1 over x power 10. Here a new idea, how could we find the term? We have to find the order of the term firstly. How could we find the order of the term? We have the first, we have a equals to x squared, and we have b equals 1 over x, and n equals 10, so we have to find r. So tr plus 1 equals 10, choose r, times 2x squared power 10 minus r times 1 over x power r. And now here we have it 10, choose r. Now the idea, we are going to separate for the coefficients. So x squared here equals x squared power 10 minus r separately, and 2 power 10 minus r. And for the second term, 1 power r and x power negative r. Because x here was in the denominator, we are going to move it to the denominator by changing the sign of the power. So 10 choose r. Now we are going to collect the like terms together. It's very important to collect the x's together. So becomes x power 20 minus 3r, because in the previous step we have x power 20 minus 2r times x power minus r minus 2r minus r equals minus 3r. And now we have the term contains x power 8, so x power 8 equals x power 20 minus r. By cancelling x and x, we will have 8 minus 20 minus 3r. So by simplifying, 3r equals 12 divided 3 divided 3, so r equals 4. So here we have the first term. Why? Because r is the order of the term, minus 1. So n equals r plus 1. When r equals 4, n equals 5. So the fifth term contains 8 power 8. To check our solution, we find the value of the fifth term. 10 choose r, x power 20 minus 3 times 4 times 2 power 10 minus 4. It will be 13,440 x power. And for the next exercise, here we have find the term 3 of x in the expansion of x plus 1 over 4 x power 3 raised to the power of 16. We have the same idea of the previous exercise. By the previous exercise we had x power 8, and here we have x power 0, because the information here in this exercise, the term 3 of x or has no x. That means we have x power 0. So to find it, we have the same steps of what we studied in the previous exercise. We have here the first term is x, and the second is 1 over 4 x power 3, and n equals 16, and we have to find the value of r. How could we find the value of r? Using the general formula for the expansion of the binomial, using binomial theorem formula. Tr plus 1 equals 16. Choose r, and choose r, and the first term x raised to the power of n minus r, 16 minus r, and the second term 1 over 4 x power 3 raised to the power of r. And the same idea here, and the most difficult step here, we have to separate the coefficients. Here we have the first term x. It's easy now, we don't have any number with x. But the second term 1 over 4 x power 3, we have 1 over 4, and we have x power 3. We have to separate them. So how could we separate them? Here we have the next step here. 16 choose r, x power 16 minus r, the coefficient is 1, and again the second coefficient is 1, so 1 power r and 1 power 16 minus r. We have 4. This 4 we can use it for power minus r, because we just move it from the denominator to the numerator by changing the sign of the power. And we have x power 3. Again we are going to change the sign of the power, because we have to change the position of x power 3 from the denominator to the numerator. By simplifying, we have to collect x with x, because we have the same basis, and we are going to add the power. 16 minus r minus 3 r equals 16 minus 4r, and 4 power minus r. And now here we have this term has no x, because it's free of x. Free of x means has no x. Means x power 0 equals x power 16 minus 4r. By cancelling the x's together, we'll have 0 equals 16 minus 4r. By solving this linear equation, we have 4r equals to 16 divide 4 divide 4, so r equals 4. Now we have r equals 4. That means we have the fifth term, because r is the order of the term minus 1. So the fifth term equals t4 plus 1 equals 16. Choose r times 4 power negative 4 times x power 16 minus 4 times 4. So the answer is 455 over 64. Now the last idea in the exercise here. How could you find the sum of coefficients of the binomial expansion ax plus by raised to the power of n? To know how could we find it, we have to cancel the letters x and y. We will have it a plus b raised to the power of n becomes a plus b raised to the power of n. This is the sum of the coefficients. So now if we want to apply it on the exercises, here we have the first one. Find the sum of coefficients of 3x plus 2y raised to the power of 8. To find it now, we have to know how could we cancel the letters. So the answer, the sum of coefficients of 3x plus 2y raised to the power of 8 is 3 plus 2. Only the coefficients raised to the same power 8 becomes 5 raised to the power of 8, which is 390,625. And the last exercise which we have it here, find the sum of coefficients of 4 over 5x raised to the power of 3 minus 5 over 4 all raised to the power of 5. To find it, we have to cancel x power 3, so it becomes the sum of the coefficients of 4 over 5 x power 3 minus 5 over 4 all raised to the power of 5 is 4 over 5 minus 5 over 4 raised to the power of 5 equals negative 0.18 thousandths. And I hope you understand our binomial expansion lesson. Thank you for your listening, and I hope you enjoy. See you in the next lesson. Bye bye.
Thank you for listening for our explaining, and I hope you enjoy with us. And the homework, you can find it in the model and in your contact number in the WhatsApp and on the model. Thank you very much.